Okay, so we will discuss about the logic gates today because we have done the number systems already. Okay, thank you. So in digital waves, waves that switches between two voltage levels representing the two states of binary values 0 or 1. So the voltage is jumping between two numbers. It can be 0 or 5 volts, or maybe 0 and another voltage, or something like, you know, it can be negative 5 volts and then positive 5 volts. So it's representing 0 and 1. So it has only two numbers. So systems are composed of a series of pulses. So you can see these pulses. So periodic, we can have digital waves either as periodic or non-periodic. So you can see in a periodic, it has a repeating curve. So you can see it is repeating from here to here like that. So is one that repeats itself as a fixed intervals. The frequency is the rate at which it is repeating. So how fast it is repeating, that we got that we say the frequency. So frequency is per second, or else it is hertz. So in a non-period, or else the relationship between the period and the frequency is period is time for one cycle, and the frequency is how many cycles per second. So there is a relationship between these two. So period, we use the letter T. Period is measured in seconds, and period is equals to 1 over the frequency. Frequency is measured in hertz. So if you consider hertz, hertz is equals to 1 over the seconds if you consider the units. So this relationship, period is the number of period is the time per cycle, and the frequency is how many number of cycles per second. So you need to have an understanding, not only for this one, especially you need this for your future topic, which we are going to do, AC signals. So this is a non-periodic wave where you don't see any repeating pattern. So it is wait, like, you know, it can have anything. It is non-repeating. Are we good? Any question? Okay, so I'll move to the next one. Can I move to the next one? There are a few things that we need to remember. The baseline is the equilibrium position. Amplitude is the distance between the peak and the baseline. So how high the peak is, or how high the signal is. Rise time is the time required for the pulse to rise from 10% to 90% of the amplitude. So if you consider a digital wave like, or else I'll just take this one, a sinusoidal one. So from 10% to 90%, this time we call the rise time. Pulse width is the time between 50% of the amplitude is rising edge and the 50% of the amplitude is the falling edge. So it's actually the pulse width is 50% of the rising, that means somewhere here, and 50% of the falling, it is somewhere here. So we will discuss them more later on. Fall time is the time required for the pulse for fall from 90% to 10%, the other way around, so from here to here. T is the period, we discuss about it, and F is the frequency, and we have already discussed that. I hope that's, you guys are okay with that. As I have mentioned, we will discuss more about the about all these things when we go to the next topic, which is AC signals. Okay, so we will discuss about them more. And today, especially, we are discussing about the gates. Mainly, you have 3 gates in your syllabus, which is AND, or NOT. So AND gate, if you see the AND gate symbol, it look like this. So by looking at the symbol, you should be able to identify or find which one is what. So do you see the differences here? So AND is always, you have a curve like this. O is, you have 2 curves like this, and the NOT is a triangle with a knot. So not has two symbols. Any symbol is okay for not. Okay, so and yeah. No, it's both the same. Both the same, yes. So we can use either any of them, they both the same. Okay. So in AND gates and OR gate, we can have many inputs and we get only one output, but not we have only one input and one output. So here, let's see what we have them different. So if you will start with the easier one. So NOT gate symbol is this, and we should be able to write the Boolean expression or an equation for that. So if your output is X and if your input is A, say output is X and input is A. So you can write the relationship between the output and the input. Output is equals to opposite of the input. So A bar. So this is how we write it. We call this the Boolean expression of the NOT gate. And also if you write the truth table, this one we call the truth table. So in the truth table, you have your input and you have your output. So what the NOT does is, whenever you have your input can be only two values, 0 or 1. So if your input is 0, your output will be opposite, which is 1. And if your input is 1, your output is opposite, which is 0. Makes sense? So it always giving us the opposite of the input. So this we call the truth table of the NOT gate. So now the other thing that we need to know is the signal. So if you have a wave like this, so you have, this is your base, maybe 0 and 1, isn't it? So you need to draw, you should know how to draw the X or the output. So whenever your A is 0, your output is 1. Am I right? So it is opposite, just the mirror image. Makes sense? Because this, whenever this one is, this is your 0 here. So this is your 1 here. Whenever your A is 0, your X should be 1. Whenever your A is 1, X should be 0. So it is opposite. So it's like the mirror image of the wave. Makes sense? So NOT gate is always having, you need to know these things. We need to know the symbol. So are we okay with the symbol? So NOT gate symbol is like that. And how we write the relationship between input and output, that we call the Boolean expression, and that is X or the output is equals to the opposite or the A bar. And we should know how to write the truth table. We have only one input, one output. So your input can be either 0 or 1. So if the input is 0, you get output as 1. And if your input is 1, your output will be 0. And we should know how to draw the waveform as well. So are we all good with that? Okay, well, let's move to the okay, AND gate. Symbol of the AND gate is this. So and so you can have many inputs for the AND gate. So let's take two inputs, A and B. Let's take, we have only two inputs, which is A and B, and our output is X. So how can we write? AND means A and B both need to be 1 to be the X1, output as 1. So how do we write it? What is the Boolean expression for this one? A and B. So A dot B. A and B both need to be. So it's a multiplication. Make sense? And how about the truth table? Truth table, you have inputs and outputs. So how many inputs in this particular example? We only have two inputs, which are A and B. Make sense? And we need to know the output, which is your X. Okay, so what can we have? We can have both zeros. Am I right? And also we can have just B is 1 and A is 0. And also we can have A is 1 and B is 0, and this one will be 1, 1. So these are the all combinations of the input. Make sense? So how we know how many combinations we should have? There is a way to find it out. So 2 to the power number of inputs will tell you how many combinations we have. In this case, we have 2 to the power 2 because we have only 2 inputs. So that will be four combinations. So we have all 4 in our table. For example, in case if we have 3 inputs A, B, and C, then to find the number of combinations, we have to say 2 to the power 3, which is equals to 8. So in the truth table, we need to have 8 combinations. Okay, so what should be the X value or the output? And A and B both need to be 1 to have X1. So which one is that? Yeah.
Finding number of combinations, it's always 2 raised to input or output.
Yeah, inputs. 2 to the power of number of inputs. So inputs, we have 2 inputs here, so that it is 4. If you have 3 inputs, it is 2 to the power 3. So that means 8 inputs. We'll do the truth table for 3 inputs as well. Okay, so what should be the output for these 2 inputs, A and B? When A and B both are 0, what should be your output? 0. And when only B is 1? 0, because both need to be 1. And means both, A and B both. And, okay? So only one we have is the last one, which is A and B both are 1. Then our output will be 1. Make sense? Any question? So can I give you time for you to draw the truth table on everything for 3 inputs? We have A, B, and C, 3 inputs. Okay, so when you have 3 inputs, how do you write the how many combinations? Combinations 8, isn't it? 2 to the power 3. So we can write the symbol. So we have, we can say we have 3 inputs, which are A, B, and C. So we can write X as your output is A dot B dot C. Am I right? And how do we write the truth table? It should have 8. So we have A, B, C, and we have the output, which is X. So we have 1, 2, 3, 4, 5, 6, 7, 8. So you can use the binary numbers to do this. So 0, 0, 1, 0, 1, 0, 0, sorry, 0, 0, 0. We have to start with 0, 0, 0. Sorry, I missed it. So 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Am I right? 1, 0, 1, 1, 1, 0, 1, 1, 1. Am I right? So those are the 8 combinations. This is binary numbers 0, 1, 2, 3, 4, 5, 6, 7 in binary numbers, isn't it? Do you have the same? Do you have the 8 combinations? So what should be the, all should be 0 except the last one, agree? In the AND gate. So that's the truth table. Okay, so we are okay with that. So if we have a, so what should be the wave for the AND gate? So you can do this if, so you can see you have to figure out where you have A and B both are high or else 1. So these are the locations. Am I right? These yellow highlighted ones are the areas where we have both A and B are 1. Am I right? So your output X, how can you tell me? It should be 1 only when both are 1. Make sense? Is it clear or not? A and B both high will be only the highlighted parts, yellow highlighted areas. Other ones, either 2, both, or else either 1 is less, 0. So your output is only will be 1 when both are 1. Is it clear or not? Okay. Can I move on? We have questions in the tutorial I have copied here, so you draw it like this. How I draw? You draw it normally below the signal. Make sense? Okay. So this will be our output. Okay, so can I give you a few minutes for you to think and do this? Operations with waveforms, input for 2 input and gate and 3 input and gate. Okay, so this is a 3 input, sorry, this is a 2 input one. Can you draw the truth tables are fine with you guys? I hope we did it. So can you draw the X or the output? How do you draw the output? Where it is becoming 1? So you need to identify where both are 1, isn't it? Both are high. So which areas are like that? So we have this and this. That's all. Agree? So how will be your output? You have a peak only these areas. Am I right? So that will be our answer. How about this? I'll give you time for you to figure this out. You have 3 inputs and you need to find out your output. Where are they in both? All 3 are in 1. Here? Where else? This one? That's all right. Okay. So then it will be like this. So you normally draw it underneath the waves. You don't have to, yeah. Okay. So we already did the truth table for 3 input and gate, so we are not going to do this because we have already done that. Determine the total number of possible inputs combination for four input and gate. How many combinations? How do we find it? 2 to the power 4, which is 16. Are we good? So they are asking just the number, so 16. It's take long time because you have to write everything. It's not long time, but like, you have to write 16 combinations in that. Okay. This one I already told you. If you know to find out the number of combinations, it's 2 to the power the number of inputs. Okay, so can I give you a few minutes for you to do this one as well? This is again AND. This one. On here, right? That's all. So it will be like this. We already did the truth table, so I didn't do it because we already did it, right? Any question? Okay, now let's see the OR gate. So the things for the OR gate are like this. So symbol, we have already discussed the symbol. So truth table, if you see the truth table, A, O, B, if 1 is 1, then the output is 1. And the expression, Boolean expression, we can write it like this. And you only, like, when you do the OR gate, the easier way to do it is for waves. You can identify where both are zeros. If both are zeros, only the output will be only 0 when both are zeros, isn't it? So both are zeros where? So only both are zeros in these areas. So x otherwise your output will be on here as well. So output will be a 1. Make sense? You find out where all three are zeros, then only those places you have the 0 for the output, isn't it? Make sense? Okay. So can I give you a question to do? Okay, when you finish, let me know. Okay. Okay. So as a summary, these are the things we have already done this part. So this is the summary. Okay. Let's move to some questions. Before the this is in your we didn't do gates, right? Did we do the practical for gates? In I think next week practical is your gate. So you have this ox or these two gates in our practical. So this one is like, you know, the truth table I have given you. Whenever we do the practical, I'll explain you, but you don't get any questions from this one for the exam. This is just for your practical. Okay, I'll explain you this part. The truth tables are like that. So when you have XO, that means it's you can see the truth table here. It's when both are zeros, it is 0. When both are ones, it is 0. Otherwise, it will be 1. So X no means it's opposite of this one. So you can see the opposite of this one here. Okay, so you will see this in the practical. We are using some gates and the bulbs lighting up, and yeah, so you will find that one there. So in this one, what is happening? We have a dot after the AND gate. So the symbol, if we separate it, it should be like this. So can you try to do the input and the output in this one? So we can have A and B, and then we can have before coming to the X, we have another one. We have to find that X bar or something. So your inputs can be 0, 0, 0, 1, 1, 0, 1, 1. So your output coming to this point here will be 0, 0, 0, 1. Now your output X will be the opposite. Am I right? Makes sense? So you can have the same thing for OR gate as well. So I'm not going to do the OR gate, but you can do it by yourself, right? So if you have OR gate, so like this, OR gate and a dot here. That means you need to I hope you can do the truth table for this one as well. OR gate. We don't have to do it if you are okay. Are you okay with the OR gate or with the not there? Okay, so if you have like this, what will happen? I mean this. You have OR gate and a NOT. So this two will be different. So OR gate means you have like this. Am I right? And the output will be 1, 0, 0, 0. This is for this. Make sense? Are we good? Are we good? Okay. Can I move on? What this means? You have NOT gate before entering A is going through a NOT gate before entering the AND gate. Makes sense? So you can have this kind of symbols. If you see this kind of a symbol NOT, that NOT means you have that circle is for NOT gate. Makes sense? Okay, so let's can you do this one? Can you tell me what we get here? So for example, how do we write the truth table for this? You have A and you have B, and you have X. So what can be, you have only two inputs, so you can have 0, 0, 0, 1, 1, 0, 1, 1. So your output is an AND gate, but before coming to that, you have to find what is happening to this. So you have to draw, you have to find out A bar and B bar. So A bar is what here? 1, 1, 0, 0. This need to be opposite. Am I right? A should be opposite. A bar means A opposite of A. Am I right? So what should be the B bar? 1, 0, 1, 0. It should be opposite of this. Now you look at these ones. And so you have 1 here, you have 0, 0, 0. So if you look at the input and the output only, you can see input is this 2 and the output is this for this particular gate. Make sense? Is it clear or not? Okay, so we'll move. I want you to do this question and I'll give you time. You can write it here. So what they say, a network of cascade inverts in the shown shown in the figure 3. If high is applied to A is high. High means you can write A or you can say high. So this one is high. If this is high, write down whether the next one is high or low, high or low. So I want you to write everything here. So for example, if A is high, when it goes to B, this should be low because it's a NOT gate, isn't it? So likewise, can I give you time for you to write this one? So if A is high, when it goes to B, it should be low. Make sense or not? Because NOT is always opposite. So if you have 1, it should be 0. When output should be 0. Input is 1, output should be 0. So likewise, can I give you time? So if A is 1, B should be 0. That means if high, then it should be low. When the low is going through this one, when it comes to C again, it should be what? High. Then when high goes to D, low. Low goes towards the E, high. Then what happens to the bottom line? High is going through F should be what? Low. So you are writing these answers as E should be high and the F should be low. So that will be your answer. Make sense? Any question? No questions? Okay. Can I give you this for you to do? We didn't do this, right? No. You can try this. Which gate is this? AND. So AND gate, to have the output, all inputs need to be 1. Am I right? So where you can find all inputs are 1. Here. Am I right? Where else? That's all, isn't it? Which one? I don't see anyone else. Do you see anything else? That's all. Because all 3 should be up. So your output will be am I right? Can you do the same thing? If you have OR gate, same waves, if it goes to the OR gate, you have all 4 inputs, and I want you to draw the output for OR gate. So OR gate, how do we do it? You find out where all 3 are zeros. So where the all 3 are zeros? Where do you see all 3 are zeros? Here? Where else? This one only, right? Nowhere else? So what should be your output? Only those are, so your output will be like this. Make sense? Am I right? For OR gate, it should be like that. Any question? No questions? Okay, so this one is O and, okay, so you need to do for O and both again, okay? I'll give you time. Where do you see all up? 1. Here. We'll do AND gate first, okay? There, where else? Here. Is that all? That's all, isn't it? So for AND gate, it should be like this. How about OR gate? You need to find out all are zeros. So it's starting with all are zeros. Where else? This is also all zeros, ending with zeros. Where else we have all 5 actually zeros. This one, right? Anywhere else? Here as well, right? That's all right. Oh, no, it is not because of this one. One is up. That's all, I think. Thank you. That's all, isn't it? That's all, isn't it? So how do we draw this? Only these ones will be okay, like this. Is that right? Something like that, isn't it? Only the green ones are zeros for O. So this is for O and this is for AND. Are we good? Any question? No question? One more. 2 more actually. This one and another one. Then we are done with the gates. I took the tutorial questions as well here. Okay, there are some number system questions in your tutorial. I hope you are okay with number systems. You can try the number system questions by yourself and let me know if you have any question. Okay, and after this we will do some revision questions after the two questions here. Which gate is this? And. Where do you see all are ones? Here. Am I right? Where else? Here. Here. Anywhere else? That's all I see. Do you guys see anywhere else? Okay. So we have to draw it like this. We good? Okay. Next one. Last one. You have to prove that these two are the same. So you can prove in different ways. You can draw the truth table. Can you draw the truth table for these two? So truth table for the first one, you have A, B, and then it is going through a knot, isn't it? So you can have X bar and X. You have two inputs. So this will be 0, 0, 0, 1, 1, 0, 1, 1. It is an AND gate, so all zeros and then 1. It should be opposite, then it's 1, 1, 1, 0. Are we good? Did you have the same? In this one, what is happening before coming to this, you have a NOT gate, isn't it? So what you need to write A, B, and A bar, B bar, then you have the X. Do you agree with that? 0, 0, 0, 1, 1, 0, 1, 1. And whenever you have zeros for A, that will be 1, 1, 0, 0. Then if you go to the B, B bar will be 1, 0, 1, 0. Now you can, this is a OR gate. Either A or B is 1, then you have 1, 1, 1, 0. Do you see that? Do you get the same? So if you look at these two outputs, you have the same output. That means what? Both are the same. So they are equal, isn't it? So how do we write the, so the output will be 0, only both are zeros, isn't it? So how you draw the wave? Find out where both are zeros. So only when both are zeros, your output will be 0. All the other times, sorry, no, I'm wrong. So when both are 1, your output will be 0. Otherwise, your output is 1, isn't it? Am I right? So when both are 1, your output will be 0. All the other ones, your output will be 1. So where you have both are 1s, here, here, and here only, right? Then those numbers should be what? Zeros. So you have your graph like this for the output. Agree or not? Okay. So that will, which one, which is? When, like, here, when both are 1, only your output will be 0. So we figure out which ones are 1. Both are 1. So both are 1 only in these green highlighted areas. So those are the ones you have zeros. The rest will be 1. Okay. Are we good? So that will finish the logic gate parts. Do you guys have any question? No questions? Okay, so we'll do some questions.